This will be the review. The first thing I want to alert you to, and there's no real outline on this, but it's from the other weeks. The first thing I want to alert you to with the review is I'm actually going to consider it somewhat important to know the statistics we've run so far. When is it appropriate to run one statistic versus another? Kind of a little review even from the first unit. Do you remember the two statistics that are kind of useful from the first unit? One was the chi-square. So we did those chi-squares. So one of the questions you're going to get, when is it appropriate to run a chi-square on something? What do you do a chi-square on? Maybe I could even answer it. You do a chi-square when it's frequency based. How many people are in this category? How many people in that category? So it's nominal data.
Are you recording this?
I am recording this. So you should know for the test, and you can go back and look in your notes, when you do a chi-square. Chi-square tends to be how many people in this group? How many people in that group? Frequencies.
Frequency base.
Yeah. 10 people had cancer. 10 people didn't have cancer. 10 people were smokers. So it's categorical variables. So categorical variables and frequencies. So you need to know when you do a chi-square. Do you think I'm going to ask you to do any chi-squares for the second test?
Yeah. Sure.
No.
Okay.
You did that on the first test.
All right. Okay.
The second statistic that we covered, the Z statistic.
Yeah.
The Z-test. What do you need in order to do a Z-test? Do you remember what you need to do a Z-test? What do you need to know to do a Z-test?
You need to know the mean
of what? I did it on...
the data.
Not the data set. We did it on ACT, SAT, IQ. You need to know the mu and sigma. You need to know stuff about the population. You need to know information about the population. When we do our statistics in behavioral psychology, do we ever know anything about the population? No. So you need to know why we would or wouldn't use the Z-test. We almost never have population information, mu or sigma. So in this unit, what kind of statistics have we covered? We've had t-tests. How many different types of t-tests?
2.
Yeah, kind of two types of t-tests. We have the independent samples t-test. Everybody's only tested once. And then we've had the paired t-test. It could be intervention or non-intervention, where people are tested more than once, either before and after intervention, or just in two different conditions, organized list versus random. What I would expect you to know for the test is you're going to get some somewhat unique situations about independent and dependent variables. I'm going to give you cases and say, what do you think the IV is and the DV? They're going to be a little different than what we've covered in class. So what is an independent variable? The variable that is manipulated. The dependent is what is measured. So you should know IVs and DVs. Is that okay then? Kind of got that idea?
Mm-hmm.
So you're going to be given data sets, and basically what I'm going to ask you to do is I'm going to say which statistic would be appropriate to do and why won't the other ones be appropriate. You're going to have to kind of share rationales for that. And then you're going to get tables, or you're going to get means. The other thing I would expect is you've done a lot of class examples where I've had 3 consecutive numbers. And you've had class examples where it gives you the standard error of the mean or the variance within groups. I would expect that you could go back to your notes and just see what those dispersion estimates are to get SEMs or other things.
Okay.
I'm just being thorough in my coverage here. So you should know these things. Let's go back to the 3 presentations then.
It's 8 middle one.
Hey, calm your gorge. Don't worry, your ride home is going to be leaving a little later. Let's go back to the, do you have the outlines for the other two classes?
No. Well, maybe, kind of.
Alexis, do you have them?
Yeah, I do.
believe I do.
Okay, can I
Which
have the
one?
first?
But it's all mixed up.
That's okay. Can I have the first one? The post-test? Yeah, I think that was the post-test.
Okay.
Okay? That's good. So, after the test, the first class, the post-test information, all you need to know for the frightening formula is that we do a t-test when we don't know stuff about the population. And it's basically the treatment effect over the error. You won't have to know the formula. You just need to know that t-tests you can do without knowing anything about the population. The differences in the mean over the standard error of the mean. On page 2 of that, I'll let you have that. On page 2, it goes through a simple example of means and standard D's and standard error of the means. What I will do is you'll get a data set on the test that won't be those same numbers. It'll be different numbers, but maybe similar to that. And I would expect you to be able to look at those numbers and get the mean, standard D. How do you go from a standard deviation of 1 to a standard error of the mean of 0.57? It's 1 over the square root of n. So you'd be able to do that. The t-scores, the standard error of the mean, if you have 3 consecutive numbers, is 0.81. If you got a printout of this, I'd expect you to just tell me what all this stuff means. Where does it come from? What do we want? What does it mean?
Okay.
All right? You might get different independent and dependent variables, so that's that page. Beverly, is that working for you? Okay, as we keep going, what was on the next page? Just another data example, the paired sample t-test. We want that difference to be large. You may be given an intervention type of design, but it won't be asthma. It might be something else. You won't be asked to get standard error of the means there, but you can do things. You also won't be expected to get probabilities. It might give the probability, and you could figure out what that means. So it's going to be a lot of table interpretation. Keep going. Let's see, same thing, reporting out in APA format. Confidence intervals. Do you guys remember the idea of a confidence interval? The best guess of a confidence interval is the treatment effect. Very precise, but low in confidence. So if the asthma program would guess a point estimate would be 5, my program helps out 5, high precision but little confidence. Instead, better to have a 95% confidence interval between 2.5 and 7.5, with the mean being 5, then you're 95% confident in that range. Beverly, is that working for you? Okay. As we continue to go, so you'll be asked about a confidence interval somewhere on the test. Then we continue on. I think that's good. That's kind of it for that particular class. Then we go to last week's class. Let's see.
Well, last week is counterbalance order.
Counterbalancing order. We do that when it's a within subject design, when it's not an intervention design, when it's organized versus random and we don't want any carryover effects. Same kind of idea, pre to post, how to write out marginally significant probabilities, and so forth. Just other examples. Once again, you will not be asked to use SPSS to do anything, but you'll get printouts and be asked to interpret, write things out, and so forth. Levine's test. Once again, we did that example today. You look at that line, and you look at that sig value for Levine's, and if it's less than 0.5, that means you cannot assume the populations were equal in their dispersion. I was explaining this to Emily last week, and I was just using the simple example. If you want to see if the Levine's test is going to be significant, just look at the range of the two data sets. 1, 2, and 3, what's the range? 2. 1, 2, and 3 billion. What's the range? Almost 2 billion.
Right.
If the dispersions are different, Levine's test will be significant. Use the bottom line. You will have one situation where you'll be asked to look at that and then report either a top or a bottom line. The other thing I will let you know is that if Levine's test is significant and it has the bottom line, that sometimes for degrees of freedom, it doesn't give a whole number for degrees of freedom. It gives like a decimal, like 6.25 for degrees of freedom. You just write 6.25. Sometimes it has a decimal for the degrees of freedom if equal variances aren't assumed. Just a weird thing.
Oh, sorry.
So you know Levine's test. You know the t-test kind of stuff. I would expect you to understand those ideas. You will be given a one-factor ANOVA. It'll probably be a 2-group idea, and you'll be asked to do a computational analysis, figure out what it means, and do some analysis off of that. From today's class, we covered a one-factor ANOVA. I think what I'll probably give to you is I might have a data sheet with like a sample printout similar to what we had tonight and just ask you, what does this mean? What does this say? Can you interpret this? So you'll just be asked to do that. Does that make sense, Beverly? So the idea is write up your notes from this week, put them together, send me a draft as you wish. Monday, July 6th, there'll be no class. I'll make the test. Would it be easier if I made the test available even on Sunday night? Or is Monday morning?
Awesome.
Sunday night? I could do it Sunday at 6.
Okay.
And, you know, just take your time and by Tuesday morning have it done. Then I'll have new recordings. And I wanted to tell you the new recordings are going to be a little bit new. I'm going to try to teach you how to do a 2-factor ANOVA. And so it's going to be one kind of big example. Try to work with it, have sheets. I'll try to teach it to you in a nice way. It'll be kind of one thing, and then when you show up to class the week after, we'll try to consolidate that and make that all good. Beverly, did you ever do a 2-factor ANOVA in your experimental class?
I think we did.
Yeah. So
I don't remember doing it, but I'm sure we probably did.
So I'm going to try to teach that to you the week we come back, and then I'm hoping we can actually keep doing the face-to-face. That'll be, or the phone call. That'll be, July 13th. On the 20th, we're going to go over regression, and then I'm actually picturing we might actually look at some articles on the very last week and actually help you come up with your competency examples here in class so you can do the SPSS and then just take the analysis home with you and write things up for the competency final. So, Beverly, I think I may have asked you about, do you think you might have a chance to actually meet with us one of these weeks, or probably not?
I'm not sure. It'll probably be really hard.
Okay, that's okay.
So,
We'll catch up with you. I think I remember the name of that city where you're located. The first name of that city sounds really familiar. So, I thank you for your attention, Miss Beverly. Do you have any questions for me?
No?
All right. Well, I think that'll do it, and I'll wrap up with the ladies here. So good job, and I'll make the acoustics if you want to listen in. So take care,
Okay.
and good luck, Beverly. I'll talk to you soon.
Okay, thanks.
Bye-bye.
Bye-bye.
Okay. Now, July 20th, we do not meet face-to-face, right?
I think that's technically the case,
Oh, okay.
but I don't know. Would you be open to?
I will be at the beach again.
Okay. So maybe we want to say on, let's see, let me just think about this out loud. That the idea would be after the
I wrote it
test.
down on my calendar.
Yep, after the test, we have the 2-factor ANOVA, and then we come back the week after that, the 13th, to learn about the ANOVA. Maybe we could do even the regression that week. Yeah, that might actually be okay. Yeah, actually, we'll plan